Welcome on board of this course. I am really happy to see that you joined this course. MongoDB is an exciting technology, an exciting database solution, and even more than just a database solution, as you will learn throughout this course. And you can use it in basically any project you're building. If that's a website, a mobile app, a desktop app, or if you're working as a data scientist, you're probably working with some kind of data. You need to store data, you need to fetch data, and you need to do all of that fast and efficiently without worrying too much about database configuration, setup, and data structures. And MongoDB is an awesome solution for that. In this course, I'll thoroughly walk you through MongoDB and teach you everything you as a developer need to know. I'll teach you how to use MongoDB, how to structure your data there, how you can depict relations in a MongoDB world, how you can do configurations on your database, and most importantly, how you can perform efficient and powerful CRUD operations with MongoDB in a broad variety of ways. This is a very comprehensive course on MongoDB, and I'm super excited to dive into it with you. Now, who am I? My name is Maximilian Schwarzmüller. I'm a freelance web developer and 5-star rated instructor here on Udemy. I got a lot of courses, and I got courses as well as free YouTube videos on my channel, Academind, where I do already use MongoDB. But the complete course on it was missing. And since it's such an awesome technology and such an awesome database, it was about time to dive into it so that you can become a true MongoDB master. Now, this is a hands-on approach course. That means there will be slides, there will be theory, because you always need that, but most importantly, there will be a lot of working with MongoDB, where I work with MongoDB and you can work with MongoDB whilst following along in the videos. So that should be a lot of fun. Now, let's dive into the course and let's start with the most important question: what is MongoDB? So what is MongoDB? MongoDB is, most importantly, a database. It's a database, but the company behind MongoDB, which is focused on that database and a couple of our products, which I'll also talk about in this course. So the company behind that is also called MongoDB. But with MongoDB, I of course mean the database. Now, the name is stemming from the word humongous, because this database is built to store lots and lots of data, and not just from a data size perspective, but also in the sense of you can store lots of data and you can then work with it efficiently, which of course also is super important. So this is MongoDB. It's a database solution. Now, of course, we already got database solutions. We got MySQL, we got Postgres, we got thousands of database solutions already. So how is MongoDB different? Well, MongoDB, of course, also is most importantly a database server that allows you to then run different databases on it. So we might have a shop database running on our MongoDB server, because the MongoDB environment basically gives you a server which you start, on which you can then create multiple databases using MongoDB. So we have a shop database. In the MySQL world, we also have databases, and in such a database, we would have tables. In MongoDB, we have so-called collections. So in our shop, we might have a users and an orders collection. We probably would also have a products collection, but this is just an example, of course. So we have these collections inside our database, and you can have multiple databases and multiple collections per database. Now, inside of a collection, you have so-called documents, which look like this. Now, these documents, if you are having a JavaScript background, might look familiar to you. They look like JavaScript objects. And indeed, this is basically how you store data in MongoDB. You use this document format, this object format, as you know it from JavaScript. And you might even notice here that inside a collection, you are schemaless. This second document does not look like the first one. The H is missing. And this is a flexibility MongoDB gives you. It is really all about flexibility. Where SQL-based databases are very strict about the data you have to store in there, MongoDB is more flexible. You can store totally different data in one and the same collection, and therefore your database can grow with your application and your application needs. Of course, typically you will have some kind of structure in one collection because your app typically requires some type of structure to work with the data. And in this course, we'll actually have a whole module where I talk just about data structures and relations, and where I will make it clear how you can structure it, how you can follow best practices, how you want to structure different related data, and so on. But you are schemaless, and that is one important thing. Now, inside a document, as I mentioned, you use these JavaScript objects to store your data. To be precise, you use a format called JSON. And this is how a document would look like. In JSON, a single document is surrounded by these curly braces, and you will see that once we start working with it. And then we have our keys in there, so that would be a key. And a key consists of a name of that key here, which has to be surrounded in double quotation marks. So name, age, address, and hobbies would be key names here, or also keys. I will also refer to them as just keys. Then we have a colon, and then we have the value of that key. So here we have max, which would be some text, a string, and therefore also has to be enclosed in double quotation marks. But you can also store numbers without double quotation marks then. You could store booleans, true or false. And you can even store nested data, as you can see. The address key, or field, as you could also call it, has an embedded document. So this again has curly braces in there, and then another key value pair. And this is another cool feature of MongoDB and its documents. You can store nested data in there. And why is that helpful? Well, this allows you to create complex relations between data and store them in one and the same document, which makes working with it and fetching it super efficient. Where in SQL, you have to write complex joins to find data in table A and data in table B, here you can fetch it all in one document and you're good to go. So this is highly efficient and allows you to store data in a logical way. Hobbies shows you another example of data you can store in a document. Here we have a list of embedded documents, and you could also have a list of strings or numbers. So storing lists is also possible. And this all together is then one document inside a collection. Now in the title it also says BSON instead of JSON. Well, behind the scenes on the server, MongoDB converts your JSON data, which is this format you see here, to a binary version of it, which can basically be stored and queried more efficiently. You don't need to worry about that. We work with this JSON thing, we work with this object thing throughout the course. So this is the data we store, this is a document, and the whole theme of this video and of MongoDB really is the flexibility and the optimization for usability. And that is really what sets MongoDB apart from other database solutions and which makes it so awesome and so efficient from a performance perspective too. Because you can query data in the format you need it instead of running complex restructurings on the server. Now, you may or may not have a SQL background, but when I started working with MongoDB, there was one thing which I found kind of hard to wrap my head around. MongoDB is a so-called NoSQL solution, because it's basically following an opposite concept or philosophy than all the SQL-based databases do. Instead of normalizing data, which means storing it distributed across multiple tables where every table has a clear schema and then using a lot of relations, instead of doing that, MongoDB goes for storing data together in a document, and it also doesn't enforce a schema on you. So we got no schemas in MongoDB. If we have multiple documents in one and the same collection, they can have different structures. That is one thing I mentioned in the last video. And this is really important. This can, of course, lead to messy data, but it's still your responsibility as a developer to work with clean data and to implement a solution that works. But on the other hand, it gives you a lot of flexibility, and flexibility is always good. You can use MongoDB for apps that might still evolve, where the exact data requirements are just not set yet. You can get started, and you can always add data with more information in a collection, in the same collection, at a later point of time. You also work with less relations. There are some relations, and I have a whole module where I talk about that, but with these embedded documents, which I already showed you, one core thing of MongoDB indeed is that you have less tables, so less collections, which you connect, but instead that you store data together. And this is where the efficiency is derived from. Since data is stored together, when your application is fetching data, it doesn't need to reach out to collection A, merge it with collection B, merge it with collection C. Instead, it goes to collection A. Then MongoDB has a very efficient querying mechanism behind the scenes so that it can go through all the data very fast when looking for a specific document. So this will be super fast. And then it finds that document and it's done. It doesn't need to do any merging most of the time. So this is really where the speed, the performance, and the flexibility comes from, and this hopefully speaks for itself that this can be useful when building applications. And this is also why NoSQL solutions, and amongst them most of all MongoDB, is super popular for read-write heavy applications, applications with a lot of workload, applications that store a lot of data, let's say smart devices, which send some sensor data every second. For such applications, but also for building an online shop or a blog, MongoDB is an amazing solution due to the performance and the flexibility it gives you. So now that I introduced MongoDB, what it is, and how it roughly works, let me take a step back and go back to the MongoDB company. As I mentioned, the company behind the MongoDB database solution is also called MongoDB. And actually, they have a couple of other products too, and I will have a look at a lot of them throughout this course. So how does the MongoDB ecosystem look like? Obviously, we got the MongoDB database, which is their core asset, the core feature, and the core topic of this course, and probably the reason why you took this course. There you have a self-managed and an enterprise solution. We'll work with the community, with the free community version in this course, which has all the features we need. But of course, I will also dive into deploying that and showing you a way of getting your local database, with which we'll play around in this course, into the web and how to use it on a real app. No worries. Then they have some tools that are related to managing that database. That is more of a system admin, database admin task. I'll not cover it in this course because this is a course for you as a developer. And they have a cloud solution. That is something I will cover because this is an amazing solution for you as a developer, because all the managing a system administrator would have to do is done for you there. And you can focus on the data and your logic there. So this is awesome, and we will use that in this course too. But we'll also work locally, no worries. They also have a mobile solution, which basically means you can install MongoDB on a mobile device to store data there directly and even work without an internet connection. They got a graphical user interface, Compass, which allows you to connect to your database and look into it with a nice user interface. We will also use that in the course, but most of the time we will not, because as a developer, you of course write code. You don't click around in graphical user interfaces, and therefore we will, well, write code in this course. And we got also some other tools like BI connectors or MongoDB charts if you're more on the data science area. This is not really something where you will write a lot of code. These are more tools that allow you to connect different analytics tools if you need that. Now, this is the entire database world, and this is of course their core feature. Hence, they have a lot of products there, as you can see. Now, they also got a relatively new offering, which is called Stitch. And Stitch is basically their serverless backend solution. So this is a bit decoupled of the database, still strongly connected, but also it offers you more than just data storage. Stitch, for example, gives you a serverless query API. And you will see this towards the end of the course, where I have a whole module about Stitch and where I introduce the core products they have in that Stitch environment. So there you will see that this is essentially a tool set, a tool which you can use to efficiently query your database directly from inside your client-side apps. So from inside your React app or anything like that. But this will become clearer in the Stitch module, of course. You also have serverless functions, which allows you to execute code in the cloud on demand. So now this is totally unrelated to the database. You can execute any JavaScript code in the cloud there. And if you know something like AWS Lambda or Google Cloud Functions, this is your equivalent. We also have database triggers, which is basically a service that allows you to listen to events in a database, like a document was inserted, and then execute a function in response to that. And that function could then maybe send an email to a user informing him about that document being inserted, something like that. And there is a feature called real-time sync, which basically is built to synchronize a database in the cloud with that mobile offline supporting database you might have on mobile devices. This is the current snapshot of their ecosystem. The focus of this course is on the MongoDB database, which we'll use locally and in the cloud with Atlas, and how you can work with that, how you can use CRUD operations, how you can retrieve your data efficiently, and all of that. But I will also dive into Compass, I will also dive into the Stitch world and introduce you to that in this course. So enough of the theory for now. Let's install MongoDB and all the tools we need for spinning up databases, for interacting with databases. And the best place to start with that is mongodb.com. Now, on this page, you got various offerings. You got cloud services and you got software. Now, cloud services are, in the end, managed MongoDB servers running on some cloud machines, so hosted by the MongoDB company. And we'll take a look at some of these parts later in the course. For the moment, let's focus on software, which is software we install locally on our system. Now, in this lecture, I'll start with macOS. In the next lecture, I'll show you how to install and start MongoDB and the MongoDB server on Windows. For Linux, I unfortunately don't have a Linux machine, so therefore there I have to point you at the official docs, and therefore you should actually stick around for a couple of extra seconds here, even if you are not using Mac, because I want to dive into those docs together with you first, before we then do continue with the macOS setup in this lecture here. But first of all, let's take a closer look at the software we can install. Most importantly, we got a community server and an enterprise server. Now, the community server is a free version of MongoDB of all you need for working with MongoDB, and that's the version we're going to use in this course. The enterprise server adds more additional enterprise level features, but this does not affect how MongoDB works or which commands you can execute. Instead, here we're talking about additional configuration or security features that might matter to you if you are a big enterprise. But for developing with MongoDB, the community server is all we need. And when it comes to deploying MongoDB, we'll take a look at these cloud offerings again later. Now, we also got more tools. Most importantly, Compass is also noteworthy. It's a graphical user interface that allows you to interact with your database and to view the data in your database. It's a little bit like MySQL Workbench for MySQL, if you've worked with that, but we'll ignore it for now. Instead, we'll install the community server, and for this we can click on it, and we should be taken to a page that looks something like that. Here you can select a version, and I'll use the latest stable one, and then your operating system. Actually, your operating system should already be pre-selected, but you can select from a wide range of operating systems here, including Windows and a bunch of Linux distributions, to make sure you're downloading MongoDB for the correct system. And then you can click this download link here to start the download and download MongoDB or these core tools that you need onto your system. Now we'll take a look at what we downloaded there in a second, but for the moment let's go to the docs here, the documentation. And here we want to go to the server documentation, which actually is a great resource to look up MongoDB features in general. And we're going to go through all these key features throughout this course. For the moment, let's dive into the installation documentation. And here we want to view the docs for installing the Community Edition. And now you can choose the guides for your operating system. And it's a great idea to go through these written guides in addition to this video, especially if you should get stuck or if you are on Linux. Now, if we install it on macOS, we got different ways of installing MongoDB. We could also install it with Homebrew, which is a command line tool you can run on your system. But we did actually download this tarball, so we're going to go through these installation steps here. And now in there, we first of all have to download this tarball, this zipped folder in the end, which we did a couple of seconds ago. Then we have to unzip it, which you can do as instructed here, but even easier than that, you can also just locate that downloaded TGEC file, which is in the end just a zipped file, and double click on it in Finder. Here I moved it into some software folder, which I created somewhere in my user folder on macOS, but you can move and extract it anywhere you want. Then I'll delete the zip file, and then here I got a folder with a couple of files in it, especially with a bin folder inside of it, where we then got a variety of executable files in the end. And for us, the most important files will be the MongoD and the Mongo file. MongoD will be an executable file that actually allows us to start the MongoDB database server, which is the server that hosts the databases and which needs to be up and running for us to interact with them and with the data in them. And the Mongo executable actually will be a shell which we can use to talk to that server. So that will be the tool we use for running queries against the database server. Now, as I mentioned before, there also is a graphical user interface you could use, MongoDB Compass, but actually for this course, we're going to stay in the shell because it is about learning these commands and query commands, and while executing them through the shell is the most straightforward way of doing so. A graphical user interface can be a nice tool to help, but it will not be our main way of interacting with MongoDB. So that's why these will be the two important things for us in this course section here. But how do we now execute these files? You could double click on them, but that's not really how we want to do that. Instead, we want to invoke them through the terminal here on macOS. And to do this efficiently, we want to make them available as global commands on our system. And the official documentation tells us how we can do that. Effectively, we got these two approaches here, which we can use. We can copy the files into this user local bin folder here, or we create so-called symbolic links. Now, this might sound a bit more advanced, and these commands might look a bit more advanced, but in the end, what we're doing with that is we're turning these executable files into commands we can run from inside the terminal on our system. Now, to make that all work on macOS, it's easiest if you right-click onto that bin folder, and you then open a new terminal at that folder. Alternatively, you open your terminal just like that, and you then cd, you navigate into that path where these files are located, so into that bin folder here ultimately, but it's easiest if you just do right click here and open the terminal already navigated into that path by clicking this option. And then what you want to do is you want to run this command here from the official docs. So copy that command, paste it in there, but don't execute it yet. Instead, since we're already in that bin folder, we want to shrink this first part here to just copy /star, which copies the content of the current folder into this folder, which we want to keep. Then hit enter, and you might be prompted for your password here. And once you entered your password correctly, which I didn't manage to do on the first two tries, as you can see, this should be done. Now, to verify that this now all worked, simply type Mongo into your terminal, and this might now give you a warning like this, so that it's not allowed to start. If that happens, go to your system preferences, and there to security and privacy, and then there click on allow anyway. Do the same for all the other MongoDB commands you might execute throughout this course whenever you get this warning you just saw. Once you did that, if you try running Mongo again, this time we get a different warning. We can click open there, and now it executes. It still crashes because actually it fails to connect to a MongoDB server, but it at least did recognize this command now, and that's the important thing here. Now, what's missing at this point, though, is the database server itself. We need to start that before we can actually successfully run Mongo, the Mongo shell, and connect to it and work with it. Now, the database server would be started by running the mongod command, but before we run this, we have to prepare our system a little bit. To be precise, we have to prepare paths, folders on our system where MongoDB will be able to store the actual database data and some log files. Because when working with a database like MongoDB, but the same is true for all databases, of course, eventually the data will be written to your hard drive, and you need to tell MongoDB where the data should be written to. Therefore, what you want to do is you want to create some path on your system where that data should be stored. And for this here, I got a development folder, which is directly in my user folder, where I will create a MongoDB folder, and in there I'll add a data folder and I'll add a logs folder. Now you can add such a structure anywhere on your system, just make sure that it's somewhere in your user folder in the end so that you have full read and write access to it. So don't create it in some reserved system path or anything like that. Instead, your user folder is a good starting point, and then some subfolder there is a good starting point. In my case, this development folder, where I then have the MongoDB folder, where I have these folders I just created. So you should create a structure that looks something like this, folder-wise. Now, once you have these empty data and logs folders, you can actually now start MongoD. Now, first of all, we can run MongoD just like this because it will fail anyways, because macOS will block it. So to work around that, again, we go to the system preferences and allow this anyways. And now we could run it successfully, but before we now run it again, we want to configure it a little bit. So we'll type MongoD and then a blank. And now we want to make MongoDB aware of the data and logs paths we just created. And for this, you add a so-called flag, a so-called option to this command, to configure this command. You do this by typing -- and then dbpath is the option name we want to add here. And with that, we can tell MongoDB where the data should be stored. So that's a special option MongoDB will be watching for. Then you add a blank and then the path where the data should be stored. And to get that path, you can go to that data path you created and right-click on it and choose Get Info here on macOS. And then you can copy this path here in the where part and paste it in here. And now just make sure that it ends with /data or whichever name you chose for your data folder. So that is the first important part. With that, we'll tell MongoDB where to store the data, and you want to add this option whenever you restart your MongoDB server. For example, if you shut down your operating system and you restarted it, and you now want to restart your MongoDB server to work with it again, you have to restart it like this again. But we're still not done. Add another blank. And here, for me, it's doing it in a new line because I ran out of space here, but it's technically still the same command in the same line. It just added this line break for readability reasons. Don't hit enter because that would confirm the command and you don't want to do that yet. Instead, just add a blank and then also add another option with -- and that's the log path option. And here we now want to get the path to our logs folder, which of course is the same path, just ending with /logs in my case, to point at this logs folder. Now for the logs, you then also actually have to point at a concrete file that should be created, so add another / and then mongo.log, like that. The name is up to you, but mongo.log is a common name for that log file. For the data path, you did not specify such a file. Now you can hit enter and you might see another warning where you have to confirm that you want to open this command, this tool. But with that, eventually, it should now start this MongoDB server successfully. And you can tell that it's successful by the fact that it does not crash and that you now started such an ongoing process. You're not back to the regular input mode anymore. Instead, this is a running process which you can always quit with Control C. So by pressing Control C. But if you do quit, you won't be able to interact with the database anymore. You have to restart it then to do that again. So as long as you are working with that MongoDB database, you want to keep that process up and running. So you don't want to close that terminal window and you don't want to hit Control C here. Instead, now we can open a new terminal window, for example, by pressing Command N here on macOS. So I still have the other process running here, and now I have my new window here. And in here, we can now try to connect to this running server. And we do this by running this Mongo command, which I showed you before, which under the hood uses this Mongo shell. If you hit enter like this, it should automatically connect to your server. It gives a bunch of log information output here, but eventually it will connect. And now that you are connected, you can interact with that server. For example, in here, you can run show DBs to see all the databases that are running on your database server. And you will have some default databases out of the box here. Now that's the point where we'll stop here. We'll pick up on this in the next lectures. By the way, there I'm also using the light theme of the terminal, but other than that it's the same. But now with that, we have that running MongoDB server on macOS. Again, if you're facing any problems here, definitely have a look at these official docs for macOS to go through the installation step by step again with help of that written guide and eventually have that running server and connected shell on your system as well. Now let's continue with Windows. In the previous lecture, we installed MongoDB on macOS and we had a look at the documentation and so on. In this lecture, we're going to install it on Windows. Now again, we're going to dive into the cloud offerings later. For the software offerings, we again want to install the community server, and now we want to install the community server on Windows. It should automatically select the correct operating system here on the right. If not, select Windows manually. And then you can simply download the MSI package, which is an installer which is more convenient to use to install MongoDB than using the zip file. So let's download this installer. And this can take a short while until it's done, since the package is rather big. But I'll be back once the download finished, and then we're going to walk through this installer together. Okay, so the installation finished for me. Now I'll start this installer and we'll walk through that together. Of course, we have to accept the license agreement, and then I'll choose the custom installation mode here. Now here we want to make sure that all these items are selected, client and server. The server will be the thing serving our databases and storing our data. The client will be a tool we use on our local machine to connect to that server, to run commands against that server and so on. And will not really use a big graphical user interface for working with our database. Instead, NoSQL databases in general are not really about configuring the database or any tables in there, because as you learned, there is no fixed predefined structure you have to set up. Instead, you really dive right into the commands that you want to execute for inserting data or fetching data. So therefore, we should make sure that's installed. And with that, we can click Next here. Now here's an important screen. Here, by default, this checkbox is checked that you want to install MongoD as a service. MongoD is a process that will be installed that you would use for spinning up your database server. And you can do that manually. And if you uncheck this, you have to do it manually. But with Windows, the convenient thing is that we can indeed keep this checked. And then the MongoDB database server will be started in the background for us as a so-called service. We can still stop and start that manually then, but we don't have to actively execute some command to bring that up. We don't have to keep it running in the foreground. Instead, it will run in the background. And therefore, I will keep this checked here. And I will keep these default settings. But now here's an important part as well. The data and the log directory. You can keep these default paths, but I want to explain what they do. Like all databases, MongoDB of course ultimately stores the data somewhere on your system. It manages the data storage for you, but ultimately data will end up in files on your system. And it will use this path here, the data directory path, for storing the concrete data in files. It will also log some messages and information and will store that in this path. That's why these two paths are needed and what they do. And with that we can leave all the settings, but I wanted to explain why we have those settings and click Next. And just as a side note, if you watched the macOS setup as well, there we did not set it up as a service. Instead, there we had some executable files which we had to execute manually to start the database server. This also works, but on Windows this here can be more convenient. So let's click Next here. Now we then also get a chance of installing MongoDB Compass. On macOS we didn't get that. We could still install it as an extra tool there. And you can keep this checked here and click Next. Alternatively, you can also always install it standalone by going to the MongoDB website and then to Software and then going to Compass there. And there, if you click on Try It Now, you can also download Compass there. And that's this graphical user interface which you can also use for talking to your database. We will have a look at Compass throughout this course, so therefore you can install it already, or you don't install it yet and instead you install it later. Hence I'll click Next here and then Install. Now once the installation is done, you can click Finish. And now as a first step, you can open up your Windows Start menu and search for Services there. And open this Services tool. Here you got all the background services that are running on your system, and if you scroll down to M there, you should find MongoDB server there as well. And it's running by default. Now this is this database server which is running in the background as discussed a couple of seconds ago. You can always right click on it here to stop it, and then this will shut down this service and therefore also the database server. And once it's stopped, you won't be able to interact with it. So you won't be able to send commands to it. Therefore, you want to start it again so that you are able to interact with it again. And that's of course then a very convenient way of starting and stopping that service. Alternatively, you can open up your command prompt as administrator. And in there, you can run net stop MongoDB to also stop this service. And once it's stopped, you can run net start MongoDB to start it again. So that's an alternative to using this services tool. It's up to you what you want to use. So now we got that server running. But in order to use that server, we now need to start that client, that shell as it's called, which allows us to send commands to the server, queries for inserting or fetching data. And for this, you should open up your Windows Explorer and then go to the path where MongoDB was installed, by default in C program files MongoDB. And here I got my server installed. But if you dive into the bin folder there, you'll also find the Mongo exe file. And that is actually an executable that you can run to start your client, your interactive shell that allows you to talk to that server. So if you double click on that, this shell opens up and now here you are connected to your server. In here, in this shell, you can now run commands to insert data or fetch data. And of course, that's exactly the part we're going to dive in this course. So that's what we're going to explore in the future here. For the moment, you can just run show DBs to basically list your databases on this server. So that's a built-in command that will be understood by the server. And you should see some default databases here. And that's it for now. At the moment, we're not going to do anything else. You can always close this shell and restart it, and you can always stop and restart the server, but as long as you want to work with it, it should of course be up and running. And with that, let's now continue and dive deeper into MongoDB and in how we can work with it. Now, before we now get started with diving into the MongoDB syntax and how we can write queries and run queries against our MongoDB database, there's one additional tool you might want to install, and that's the MongoDB shell. Now, actually, we already did install a shell together with the MongoDB server in the last lecture, and we already did start the shell there. That was that thing, that tool, which we executed in the command line or by double-clicking on it on Windows to then connect to our running MongoDB server. So that tool which we'll use for inputting commands, for sending commands to the server. But depending on the point of time you're watching this course, that shell might be the old shell, which is perfectly fine to use. There's nothing wrong with it, but there is a newer shell available, and you either already have that or you need to install it separately. And you can tell whether you already have it by the look of it and whether installing it separately changes anything for you. Now, I did record this course with the old shell, but you can follow along just fine with the new one because the commands I teach are exactly the same. The shell just looks differently, and the new shell simply has some extra convenience features. It has nicer formatting and so on to present the output in a nicer, more pleasant, and easier to understand way. But the commands I execute are the same, so nothing changes about that. You learn all the things you need to learn about MongoDB in the correct and up-to-date way with that course, even though I'm using the older shell. Now, to get that newer shell, you can search for MongoDB shell, and you might find this link to the legacy Mongo shell, which is the older one, which you already might have installed automatically together with the MongoDB server. And you should also find this MongoDB shell download link. Alternatively, you can get there on mongodb.com by clicking on Software, Developer Tools, and then there choosing the MongoDB shell. And then here you can click on Download Now to be taken to that same page. Now here again, you can choose your operating system. There are different versions available for all the operating systems, and you can then simply download that shell. On Windows instead, you would have this installer, which you download. And once downloaded, we simply execute it and then walk through that installer. We can keep that default path which it chooses here and then choose Next and start this installation. So it's really straightforward here. And then we're done on Windows. Now back on macOS, here we have to extract that zip file and we'll get a new folder which contains such a bin folder. And in there, you have two different files. And for us, the Mongo shell file is the most important one. But you can grab, and you should grab, both files and copy them. And then move them to the directory where you installed your other MongoDB tools. On macOS, that should be your USR folder. And you need to make sure that you can view hidden folders and files to view that. You can do that by hitting Command, Shift, and dot. And then in that USR folder, go to local bin. And that's where we copied the other Mongo commands before when we installed MongoDB on macOS. So now move these two new executables into that folder. You might need to enter your password to do that. On Windows, you can now open your Windows menu, the Start menu, and there search for Mongo sh, so Mongosh, and execute this command, this tool, which is the Mongo shell we just installed. And this will open up the Mongo shell and connect to your running MongoDB server. So of course, therefore, you need to have such a running MongoDB server, this running service here in case of Windows, so that this connection succeeds. On macOS, we would typically open our terminal and simply execute mongo as a command there, and then connect to our running MongoDB server. And for this, of course, we need to have our server up and running there as well. That is a must-have. Now you can ignore any warnings or any messages you might see here. We don't need to worry about them right now. Instead, we can now use this shell to interact with the database. And then this shell is connected on both Windows and macOS. And this shell, in the end, supports the same commands you could also use in the old shell. So you could use either of the two shells, but it is more future-proof to follow along with this newer shell. And maybe you already had this shell as a default shell right from the start when you first installed MongoDB in the last lectures anyways. Now, just as before, you can run show DBs in here to see a list of your databases. And there we got some dummy starting databases, but I'm now going to continue with this new shell here. So now that everything is set up and you should have a working MongoDB server and the shell connected to it, let me clear this screen by running CLS, and this only clears the screen, doesn't do anything else. And now let's work with the database. Let's get started working. First of all, you can type show DBs to see existing databases. And you do start off with free default databases that store some metadata. We don't need to worry about these. Now, first of all, let's connect to a database with the use command. And you can connect to a brand new database by simply typing its name. Even if this doesn't exist yet, it will be created on the fly once you start inserting data. Now in there, you can create a new collection also on the fly because no collection exists right now. And you do this by typing db. This refers to the database you're currently connected to, so shop in my case. And then the name of the collection where you want to insert data. Let's say products. And this also doesn't need to exist yet. And then you can insert one new product with the insert one command. And you pass this JSON object to it. So these double curly braces surround the data you now want to insert into this collection. And there you can add your keys, your key value fields, like name, max. Now the good thing is, here this would work, but you can omit the quotation marks around the key name here in the shell. Not around the value, because this should be some text, and text is marked by quotation marks, but around the key name you can omit it. This is simply a little feature. It will be stored with the quotation marks behind the scenes. Now we can add a second value by adding a comma, and then the age, 29. And now we will insert a document with the name and the age. However, for a product this doesn't make too much sense, so let's maybe name it a book, and then give it a price of $12.99. So if you now hit enter, you should get this command, which basically confirms that the data was inserted into the database and that MongoDB automatically generated a unique ID for it, which it returns you here. Now let's have a look at our data then, right? This can be done by simply running db products. So again, the currently connected database, and then the collection we stored the data in, and then by typing find. This gives us, if you add no other arguments, which we'll do in the course, but not right now, if you add no other arguments, this will give you all the data in that collection. Find. So this gives us the one entry we added. And here you see the quotation marks around the key names too. Now, there also is another version of this. You can add .pretty at the end to simply output it in a prettier way. It's still the same data, just easier to read. Now, try it on your own. Pause the video, try it on your own, and add another product on your own. Also, try adding name and price, and also one extra field, like the description with some dummy text. Very successful? Well, you would repeat db products insert 1. And by the way, if you repeat a command which you executed before, you can also just press the up key on your keyboard to cycle through your past commands. This allows you to quickly go back to a past command, simply edit it a bit, and re-execute it. This will not change the past data. It will be treated as a new command, but it's easier for you. You don't have to write everything again. So here we could add a t-shirt with some price. And as I said, now let's also add a new key, description, where I say this is a high quality t-shirt or whatever you want. If you now hit enter, this will be inserted as well. And now let me clear the screen again with the CLS command. And let me execute find pretty again. And now we see two documents in that collection. And you also already see that schemaless thing. Our documents don't have exactly the same structure. Now let's take it one step further and let's insert another document. By the way, you can press Alt and then left arrow to jump through these words quicker. And let's name this computer. Ramp up the price a little bit. And then simply type a high quality computer because I'm really creative when it comes to text. And there, let's add some details. And this now will be an embedded document with another pair of curly braces inside of that other document. And here we could have something like CPU, and that is, let's say, the Intel i7, this one. No, I'm not getting paid. I don't know if that even exists, but I think it does. And memory, let's say there we have 32 gigabytes, like this. And now if I insert this and I find them again, now we see all three, and you also see that embedded document. So this is just playing around with the shell here. Of course, we can also delete and update documents, and we can filter when we're retrieving them. We don't have to always retrieve all of them, but that's just our first real quick start. This is how we will work with MongoDB for a big chunk of this course. And now let me show you how this relates to the real world, where you would, of course, write an application with PHP, with Node, with C++, and would interact with the database from there. So how does that shell stuff you're learning in this course relate to that? So for this course, we will primarily work in the shell to see all the commands and the different ways of using these commands, because the shell is a great neutral ground for working with MongoDB, because I don't know if you're building a PHP, a Node, a C++, a Python, or whatever application. And I want to teach you something which you can apply to all use cases, and that is the case with the shell. But of course, in the end, you will build an application with a programming language where this app should then issue these commands against the MongoDB server. And for that, you can click on Docs on the official page. And then on the doc page, click on MongoDB drivers, because these drivers are packages you install for the different programming languages your app might be written in. As you see, you got drivers for all kinds of languages. And these drivers are then your bridges between your programming language and the MongoDB server. And as it turns out, in these drivers, you use the same commands as I use in the shell, just adjusted to the syntax of the language you're working with, of course. So for example, if we have a look at the Node.js driver and the Python driver, let's see how we would work with those. On the Node.js driver documentation, if we click on latest documentation, we can quickly have a look at the quick start guide to see how our code would look like. If we use that, you see how to start your MongoDB database and so on. And what you will see there is that here, you also in the end just reach out to a database. Then instead of typing the collection name, you have a collection method to get access. But you would look into the official docs, of course, when using the driver. So these are tiny differences which you quickly find out there. But then on the collection, you again run insert many. We haven't seen that yet. We'll see it in the course. This exists in the shell in exactly the same way. And you insert data in exactly the same way. So the core features are exactly equal. Let's also have a look at Python to prove that. Here I'm on the Python driver page. Now let me quickly dive into the tutorial so that we see some code for that. So here you see for Python, you would install a package called PyMongo, which is the official driver for Python. You then connect and so on. And again, you in the end just get access to a database, then to a collection, here again by just using that collection name, and then you simply insert one, now using Python syntax, where you happen to write methods like this with an underscore and this snake case. But then you insert one post, which is just such an object, a Python map in the end. So you see, the syntax of the languages obviously differs because, well, they're different languages, but the general way of working with your data does not change at all. You work in exactly the same way as in the shell. And actually, this is something we'll build later in the course. This is a complete Node application using MongoDB, and here you also see some code in action where I insert a new product, and this is something we'll build in the course so that I can teach you how to move from the shell to the drivers. But I hope this makes clear why we work with the shell. It's the neutral ground on which we all can agree so that you can take that knowledge on how to insert, how to configure your inserts, how to query data, how to filter data, how to sort data, so that you can use that knowledge with any driver you want and you are really flexible regarding what you build. So we're almost done, no worries. It's soon time to get our hands dirty. Now let me quickly give you an overview over how exactly you will work with MongoDB and what MongoDB exactly does behind the scenes. So we can generally differentiate between the application, so let's say your node application you're creating, and the data layer. Now in your application, you will have some front end that can be a single page application, that can be a mobile app, that can be the views your Laravel or your node app renders. You'll then have a backend, your server, where you have your server-side logic, and then you have your data layer. So you have the database, the data storage, the files on a file system which hold your data in the end. You have the MongoDB server, and you have on the backend server, where you will write your code, you have these drivers for the different languages. Now the drivers will interact with the MongoDB server. The MongoDB server is what we start with the MongoD command, by the way. Now the MongoDB server will actually not directly write the data into files, but talk to a so-called storage engine, which you could replace with your favorite storage engine, but the default one, called Wired Tiger, is actually an awesome storage engine which allows you to efficiently work with your data, store it efficiently, and so on. So the MongoDB server basically gets the query from your driver or from your shell and then just knows I want to insert something and basically forwards that information after doing some other things to the storage engine. And the storage engine then stores it in files in the end. And instead of the drivers, you can of course also use the Mongo shell. There you can also write all the queries, and as you will also see in this course, you would also use the Mongo shell as a general playground and also for administrating your server, because that is not something your app will do. If you have to configure something, you would do this as an administrator from your company network through that shell, which is your direct access to the MongoDB server. Now, if we have a closer look at the data layer with the server, the storage engine, and the file system, then we actually have to differentiate between writing and reading from files, which is a bit slower, and writing and reading from memory, which is faster. The storage engine actually does both. It loads a chunk of data into memory and manages that such that the data you often use is in memory if possible. It also writes data in memory at first, so that this is really fast, but then of course it also goes ahead and stores data in the database files. And I will dive a little deeper into that later in the course, but in general you need to be aware that you always talk to the MongoDB server, and behind that server, the server talks to the storage engine, which manages your data and stores it in files in the end, but also in memory in between, so that you can work with the data in a very fast way. So this is how the MongoDB server works behind the scenes, you could say. So with all that talking and theory, we all want to get started. So what's in this course? In this course, we're almost done with the introduction, and we'll then move on to the basics of MongoDB, basic operations, and most importantly, the basic CRUD operations. CRUD stands for create, read, update, and delete, which are the core operations basically any application will have to do. If you're a newcomer to MongoDB, you should absolutely start there. Well, you start here, but then this is the first real content module with which you should start. After that, we'll have a look at data schemas and relations. How do you model your data? How do you find the right balance between having that flexible document schema and still using a schema in your app? How do you relate different documents? We'll have a look at that in this module. Thereafter, I'll dive a bit deeper into working with the shell, some different things you can configure there, and how you can, for example, run that MongoD server as a service on Mac and Linux. And we'll then have a look at the graphical user interface, Compass. We'll not really work with that throughout the course, but I still want you to know it and to understand that you can use that to look into your data. Now, after that, we're back to the shell, and we'll dive deeper into create operations. That is where you can start if you have some basic understanding. So if you're not a total newcomer, but you know basically what MongoDB does, you could skip the other modules if you want and dive into that. And we'll not just have a deep dive on the C of the CRUD, we'll also have a deep dive at reading, so filtering and querying data, at updating, and at deleting data. So a lot of deep dives there to show you all configuration options, all filters, and all different ways of getting that data you need. Now thereafter we'll have a look at indexes, a feature that allows you to speed up your queries. I'll talk about the advantages and disadvantages and how to use them. If you're an advanced user and you know all that CRUD stuff already, this might be the entry point you want to use, so you could skip forward to that if you're pretty confident that the rest will be boring to you. Now, after indexes, we'll work with geospatial data, because MongoDB is actually really great at storing locations and at querying that, so that you can do things like, I am here, which is the closest restaurant. That is really easy to do with MongoDB, as you will learn in this module. Now thereafter we'll have a look at the aggregation framework, which is a more powerful way of retrieving data from your database, and you will learn how you can use that and how you can build complex aggregation pipelines with the help of MongoDB. It's then time to work into a special kind of data, into numeric data. I will teach you how to work with different kinds of numbers and what's special about that in MongoDB. Well, and with that out of the way and with these core features covered, I'll dive into a crucial feature, security and authentication. How do you secure your Mongo database? What's to that? And how can users authenticate against it? And with users, I mean database users. So for example, your application or you as a real person using the shell. Thereafter, we'll have a look at performance, fault tolerance, and deployments. So how can you improve the performance? What are important factors? And how do you, in the end, get your local MongoDB environment into the web, into the cloud, so that you can really use it from anywhere and not just from your local machine, which is great for practicing and for working or for developing, but not really for running this in production, obviously. Thereafter, we'll have a look at a cool feature called transactions, which was added with MongoDB 4.0. And we will learn how to move from the shell, so from the knowledge you gained with all these shell operations, to the drivers. And we will build an entire application there, a Node React application. And you don't need to know either to get a lot out of that module, to learn how you can use the driver, the Node driver in this case, and use the knowledge you gained in the course to quickly create an amazing application. Thereafter, I will conclude this course by diving into MongoDB Stitch, which is this other offering MongoDB has with the serverless functions, the triggers, and so on. You will learn how you can use that to build, together with the MongoDB database, a complete application where you focus entirely on your business logic and data, and you don't have to worry about creating REST APIs, configuring servers, or anything like that. So this is what's inside the course. I hope you'll like it, and I'm super excited to dive into it with you. So now we're ready to dive in, and now I just want you to get the most out of this course. To get the most out of the course, watch the videos. This is obvious, but watch the videos and watch them at your speed. You can slow the videos down in the Udemy video player, or you can speed me up and really adjust this to your requirements. If I'm talking too fast, slow me down. Am I going too slow? Speed me up. Maybe skip lectures if you already know what I'm teaching in there. It's an on-demand course, so take advantage of that. Additionally, pause and code along, or type the commands along with me. Play around with MongoDB. Since it's running locally, you can't mess it up. You can always delete that database folder you created and start from scratch. But play around with MongoDB and follow along, because being active always gives you more than just passively watching the videos. In addition, make sure you do the assignments. There are a couple of assignments in this course which are there for you to practice. In the assignments, I always show my solution for you to compare, and being forced to solve a problem on your own first, of course, gives you an opportunity to really see if you really understood a certain concept. Now, additionally, I will point at the official docs very often, because the docs are very good and detailed, and if you need some niche case, or you just want to read something, or you just want to look something up which I explained somewhere in the course, but you don't know where that was, dive into the official docs and also use Google. That's a great additional resource to this course, because with that you'll learn to solve your problems on your own, which is always the best way of learning. You have to learn how to solve problems on your own. Take the course, get the basic knowledge, get the advanced knowledge too, but then also dive into problems you're facing on your own and solve them. Now, if something is unclear at any point, or there is a problem you can't solve, also use the Q&A section of this course. I'll do my best to reply there quickly, but also please help other students there. Don't just ask, also answer. Because by answering, you'll become a real pro, because answering is so much harder than asking. And if you answer something which is not entirely correct, that's no problem. You'll be corrected and you'll learn again. So really use this as an opportunity to also challenge yourself and grow. And with that, we got everything we need. We got the basic theory. We got everything installed. Let's dive into MongoDB and learn how to use it to its fullest potential. So let's dive into the core basics you need to know when working with MongoDB, with the data or the documents you store in there. And let's also dive, and that's really important, into all the CRUD basics. CRUD stands for create, read, update, and delete. And these are the typical operations you do with your documents. You create documents, you want to, well, find, retrieve, or read them. You want to be able to update and change your documents. And obviously, in a lot of cases, you also want to delete some data. So we'll dive into all these core basics in this module. To be precise, we'll have a look about the core basics or the core concepts about collections and documents and how to work with these. We'll have a look at the basic data types you work with in MongoDB and how to, well, store different data in your database. And we'll have a look at these CRUD operations I was referring to. I will show you which kind of queries you can run to insert data, to find data, to update or to delete data. And therefore, by the end of this module, you'll have a very solid understanding of the core concepts behind MongoDB and the core concepts you need to work with data in MongoDB. So let's get started. Even though I already showed it in the first course module, it's really important that you understand how databases, collections, and documents are related. In a MongoDB world, you have one or more databases on your database server. And each database can hold one or more collections. A collection would be a table in a SQL database. Now, in that collection, you have these documents, multiple documents per collection. And the documents are really the data pieces you're storing in your database. Now, important, when working with MongoDB, you will see in this module already that the databases, the collections, and the documents are all automatically created for you. They are created implicitly when you start working with them, when you start storing data. That is really convenient. Later in the course, we'll also learn a way of explicitly creating new collections, which allows you to configure them a bit further. But this is a cool feature which makes getting started super simple. Now, this is the core concept you always should keep in mind, and the relation between databases, collections, and documents you always should keep in mind. And now with that out of the way, let's actually bring up that Mongo server again, connect to it through our shell, and again see how we can store data in there and which kind of data that is. I'm back in the terminal, and I now again want to start my MongoDB server. Here on Mac, I'll do this with sudo mongod. And make sure you watch the installation videos in the first course module to get this up and running on Windows or Mac OS or Linux. So with that command, I'm prompted to enter my password. And with this entered, it will start up my MongoDB server using the Wired Tiger storage engine. Now, this is the server up and running, and you need to keep this process running. So don't close this window, don't quit this process yet. As you can see, it's now waiting for new connections on port 27017. By the way, if you wanted to use a different port or you're facing issues with this one, you can use a different port. And now I did quit the server by hitting Control and C. You can use a different port by specifying -- port when starting up the server, and then you can, for example, choose 27018 as a port. And now you see it would be listening on that. So that's just a tiny piece of information which can be useful in case you're using that default port for something else. So with that up and running, let's keep that up and running and open a new additional window in the terminal. And in there, you can now run Mongo without a D at the end to use the Mongo shell and automatically connect to the up and running server. Now here, however, I get a connect failed. And that happened because by default, it tries to reach the server on port 27017, which is obviously not the port I'm running on. So I can connect by using mongo -- port and then using that port where my server is running. And now you see this did connect successfully. With that, we did connect again. Now you can run CLS in here and hit enter to clear the window. I'm still in the shell here, and if I scroll up, I see all the old output. CLS just clears the window. And now we can start running commands again and work with our database. Now, before we actually run any commands, you might be wondering why I'm using the shell. Because when you're building a real application where you use MongoDB, you will of course not use the shell for that. You will use one of the MongoDB drivers depending on the programming language you're using. And on the official docs, a link to this page can be found in the last lecture of this module, by the way, you find an extensive list of all the drivers MongoDB offers. And as you can see, there are drivers for C++, C#, Java, Node.js, PHP, Python. So all the important server-side or desktop-side programming languages. Now, depending on what you're building for, you would of course choose your driver here, follow the installation docs, and then embed it into your application code. But in this course, as mentioned in the first module already, we of course want to show you an approach that works for every language. And therefore, we'll use the shell here. The shell allows us to write queries which are very similar to the queries in the different drivers. The shell is actually based on JavaScript, so it's extremely similar to Node.js. But if you check out the docs for the other drivers, or even better, in the official docs here, if you go to Getting Started, and you find a link to this in the last lecture too, you can also see that there you find a document about the CRUD operations. And you don't need to worry too much about that right now. We'll learn all about these operations in this module. But if you check out any article there, you can actually switch between the different languages. And the interesting thing is, the default always is the shell. These are the commands we'll write. But if you then switch to Python, for example, you see this is pretty similar. We had insert1 in the shell, written like this. Now in Python it follows the Python naming standards, but it's still insert1, and it's configured and used in the same way. And this is true for all the programming languages. It of course uses the syntax of that language and the best practices you should use for writing code in that language, but the way you use it, the way you pass data in and you can configure it, always is the same. And this is why we use the shell here. Now, with that out of the way, let's start using that shell, which is connected to our local Mongo server. And let's finally add some data and learn more about the data types we can use and how we can interact with data in general. In the shell, you can run show DBs to see which databases you have on this MongoDB server. And as you can see, as I'm just starting out, I got no databases in there. You might even just see admin and config here if this is brand new, but that will be fine too. You don't need to create any of these default databases. The default databases here simply exist to store configuration for this database server, or for example, the admin database will allow you to create users and roles and how people can use and interact with the database. All topics we'll cover later in the course. So we got no database in here. We can switch to a database with the use command though. And you can even switch to databases which don't exist yet. So for example here, I want to start with some flight data. So I'll name it flights. And you can choose any name you want. If you hit enter, you see that we switch to the DB flights. But if I type show DBs, we still don't see that, even though I did switch to it. The reason for this is that this database does not get created before we start entering data in there. But if we do start entering data, it will be created automatically and implicitly, so we don't have to create the database in advance. Now, as you learned on that slide, we store data in collections. So we don't just need access to the database, but also to a collection. Now, we got our flights database, and in there, let's say we want to store some flight data. You can reference the database you're currently in, so in our case, the flights database here, with db. And then you chain commands by typing a dot and then the command. And one command, in quotation marks, is that we type the name of a collection we want to interact with. Let's say we have a flight data collection named like this, and this name is also up to you. Now, this is a collection which also doesn't exist yet, but just like a database, it will be created on demand once we start inserting data. Now, to insert data, we type another dot, and now we can type some query commands. Commands that allow us to get data out of the collection, would be hard right now because there is no data in it, or commands that allow us to add data. And there we got the insert one command, for example. As the name suggests, this inserts one document into this collection. Now, important, make sure you got the casing and the name in general correct. You don't have a typo in there. It's one word with a capital O. And now between these parentheses at the end here, we pass the data we want to store. Now, a document is always defined with curly braces. If you're coming from a JavaScript world, you will know this syntax. There you also create objects with curly braces. To be very precise, we're not creating a JavaScript object here, but a JSON document. And JSON documents are also delimited or surrounded by curly braces. Now, in that document, we now have key value pairs. Now, let's inspect how that looks like and how that works before we finally add our data. So here is some data I prepared. Now, you find that data attached to this video, by the way. It is a JSON file, and this JSON file actually holds an array, hence the squared brackets here, of two JSON documents. So this is one single JSON document, and this is another JSON document. And we enter one such document with insert one. We don't insert both. We insert one such document with insert one, and this would be one piece of information about a flight. Now here I got these key value pairs, and that is how a JSON document is basically made up of. You have names, which you enclose between double quotation marks, and these double quotation marks are important and have to be used. And then you got the values for these names or keys. And here the values can be different kinds of data. Here we got a string, so some text basically, which is surrounded by quotation marks. Here we got a number though, and there we don't have quotation marks. So the values don't have to use quotation marks, only the names here. The values can be strings and then they have quotation marks, but they can also be numbers, or like this, a so-called Boolean, so true or false. This also has no quotation marks. There also are some other types of data which we'll see throughout the course. These are three very important types of data which you'll use a lot though. So this is one JSON document we could enter. So let's grab this document. Again, you find this file attached, and just that one document, including the curly braces, but not the entire array. Grab that document, and then back in your terminal here, you can copy that document between those braces. Important, before you copy it in, delete the closing parentheses, then add it, and then close it. Now if you hit enter, you should see this message here, which basically tells you that this was accepted and was inserted successfully, and that it also assigned an automatically created ID. Now that's a feature provided by MongoDB. Every document you enter gets a unique ID. And actually, you need to have a unique ID on every element, but as you saw here, you don't need to specify it on your own. MongoDB gives you one. It's of type object ID, so this is another type supported by MongoDB, which we can use. And we can see it if we now simply have a look at our flight data. Let me clear the console. And again, if I now access flight data, so this collection, now instead of inserting, we can use find like this. And if we use it like this, it will simply return all the documents in this collection. You can also add another dot and then pretty as a function, and this will just make sure that the output we get back is formatted in a pretty way. That's the only thing it does. Find without pretty will also work. It'll look like this, but, and you can press arrow up to repeat your last command, if you add pretty, it looks like this, which is easier to read. And there we see all the data we entered plus this extra underscore ID, which was added automatically by MongoDB. And this object ID object is simply a special type of data provided by MongoDB, which is a unique ID that also allows you to sort your documents, because it will also have some timestamp data in there, you could say. So this ID also can be used for sorting, because it's guaranteed that if you would add another document right now, this would be treated as a more recent document than this document we see here due to that ID. But that's some behind the scenes stuff. The important part is we got our data in there. You still see we have the same data types we added, like the number still is a number. There are no quotation marks around it. And this is now valid JSON data inserted into our database, or into our collection in that database, to be precise. Now that we added some data into our database in the last lecture, let's come back to that JSON thing. Because actually, MongoDB does not use JSON but BSON, which stands for binary JSON, for storing data in your database. Now, you don't really need to care too much about that, because all you will write and see will be JSON code, like we did it. So this is JSON code, this is what we used in the last lecture, this is also what we see when we retrieve data from MongoDB, but behind the scenes, MongoDB actually uses BSON data. This conversion is done by the drivers. So this basically takes your JSON code and stores it in binary data. And this is simply done because, for one, it is more efficient to store than JSON data. So it's faster and more efficient from a space, from a size perspective. And additionally, it supports additional types. Because, for example, that object ID thing we saw in the last lecture is not valid normal JSON. If I were to go into my editor, which is Visual Studio Code, which you don't need, but this is simply an editor you can use for coding, and I would manually add an ID field here and set this equal to type object ID with some text in there, you see that my editor doesn't like this because it's not valid JSON. Now, it is not valid JSON, but MongoDB can actually understand and take this and store it in its binary data. And there are some other types too, like for example, you got different types of numbers with decimals and very big numbers, and these are stored in different ways behind the scenes. You don't need to care too much about that, but this is something MongoDB offers you. This special data type, other special data types, and very efficient storage in general. We will always work with our data like this though, so in JSON format. And there's one other important thing you need to understand about this data. If I add another piece of information into flight data with insert 1, so if I add another document, and this time I'll type it manually, when adding data like this, you can actually omit the quotation marks here as long as there isn't a white space in the name. So we could also have departure airport like this, and this would still be accepted. So I don't need to wrap the name into quotation marks here. You can still do it to be very clear that this is JSON, but, well, we know it's JSON, and you can use it like this as a shortcut. The value, if it's a string, still needs to be enclosed in double quotation marks, though. So if we had Berlin Tegel as an airport here, and then let's say we have the arrival airport, which is Heathrow, then we could write it like this. We can now also theoretically save it like this, even though the aircraft distance and the information whether this is an intercontinental flight is missing, because you can have mixed documents in the same collection. If you add the data like this, you still see this is accepted. And if I now access all my flight data and find it and pretty print it, you see both documents exist in there, even though they have different schemas. Now we'll dive a bit deeper into schema design and how we should structure our data in a separate module, but I also want you to take away and keep in mind that in MongoDB, two documents in the same collection don't have to have the same schema. Often you will have at least some intersections or completely equal schemas, but it's not a must. One other thing you have to know is that this ID, which is auto-generated, you don't have to use the auto-generated ID, you just have to ensure that you have a unique ID. But if you can ensure this, you can also assign IDs on your own. So if I add the same entry again with departure airport and arrival airport, I can add underscore ID in there as an extra field, and it has to be underscore ID. So not just ID, also not ID with a capital character, underscore ID like this. And then you can use any ID you want, a number or another string like Tixel LHR1. This can be done, and you see this was also accepted and inserted with this ID. So if I again print all the results here, you see we got our two old results and this new one does now not have an object ID which was generated for us by MongoDB, but our own ID. If I try to enter the same entry again with the same ID though, and that's the only thing which is the problem here, not the other data may be equal as you can see here, but if I use the same ID again, we get an error. And in the end, this error is simply telling us that we get a duplicate key error in this collection and that the duplicate key is the ID, which is not allowed. So this is the error we're seeing here, and this is something you should also pay close attention to. With those basics about the data, the documents, and how we work with data out of the way, let's shift our focus towards the CRUD operations and how we work with the different CRUD operations we may use in MongoDB. Now, first of all, what is CRUD all about? Why does this matter? You can use MongoDB for a broad variety of things. You might be building an application, or you have some data which is shipped to you as one file and you just want to run some analytics on it, or you're an administrator of a database, of a Mongo database. In all these cases, you will have to interact with the database. Now, in the application case, you might have an app, a mobile app or a website, where a user interacts with your code in the end, and that code can be written in Node.js, PHP, can be a desktop app written in C++, really no limits there, and you will have your MongoDB driver included in your application then. In the other cases, like for analytics, you might be using the business intelligence connector MongoDB offers, or you directly use the shell or some other import mechanism provided by your favorite BI tool. Or as an administrator, you'll work with the shell, like we're doing it right now. In all these cases, you want to interact with your MongoDB server. And for an application like a website, you typically want to be able to create elements. You want to be able to read, update, and delete them. Let's say you're building a blog. You want to be able to create new posts, to deliver those posts to your users. You want to be able to update these posts, so to change them, or maybe even delete them. With analytics, you also at least want to be able to read the data. You might never change it, but you want to read it. And as an admin, you might want to do all these things, to fix some data or to play around with it as we are doing it. So these are these core CRUD operations. And in the end, these operations are the only thing you do with your data. This is what you have your data for, to create it, manage it, read it, all these things. And you do these things with the MongoDB server, and they're, of course, in the end, on a collection and the documents in that collection. Now, for these CRUD operations, we have a couple of important queries you should keep in mind, and you'll also find in the official docs, of course, in case you want to check out all the details or dive a bit deeper. There's insert1, which we already saw. Insert1 allows us to insert some data into a collection, and all these methods I'm showing you are directly executed on a collection, as we did it in the last lectures. And we can also pass some options along with insert1. We'll not worry about that right now. We'll dive into that later, though. Besides inserting one document, we can also insert many documents, by the way. So if you have a use case where you need to insert more than one document at a time, you can do that too. This is important for creating data. Now, for reading data, we got find, and find also allows us to pass in some arguments, Right now we're calling it without anything, just find empty parentheses. Now you can pass in a filter, and filters are very powerful. They allow you to narrow down the data you're retrieving, something you of course often want to do in a database. And you can also pass some options to find. And again, we'll take a close look at all these options and filters throughout the course too. You also got find one. The difference here is that find finds all matching documents. Find one simply gives you the first matching document it finds. Update one is then useful for changing one piece of data. And just as we can also insert many documents at once, we also have update many. Now, the update functions take 3 arguments because we can pass a filter to narrow down which document or documents to change, then the data describing the change, so what should be changed, and again, some options we can use to configure that process. We also got replace one in case we just want to replace a document entirely with a new one. There also is delete. We can delete one or delete many documents in a collection, and there we also pass in a filter to find out which document or documents to delete. Now, let's see all these things at an example. Again, having a look at our flight data here, which could look like this, basically the data we already worked with. And there, let's say this is the data we're using on our application. Our application might be a website where people working at an airport or at an airline can schedule a new flight. Therefore, they would create a new entry in our flight data collection. They can change information about this flight, so they can update information, for example, if the aircraft changed. They can cancel the flight, let's say, so they can delete it. And they can also display flight information on their own website in the mobile apps for their passengers. And therefore, they need to be able, or you need to be able, to read the data from that collection. This is our little example here, using the data we already set up. So let's get started and play around with these CRUD operations and our data. Back in the shell, and still connected to that same MongoDB instance we used earlier, let's again check out our flight data collection with find. And as you saw, use find pretty to get a pretty output. You see we got 3 documents in there. We got the document with our own custom ID. We got the other document with incomplete information but the automatically generated ID, and our original document. We already saw insert 1. Now, let me actually start with clearing this database now, before we then insert data again, but this time with insert many. Now, to clear the database, we have to use a delete command. And we can simply use our flight data collection, because all these commands are always executed on a collection where you want to add or delete documents. And there we got delete one or delete many. Now here I want to clear all the data, and for this actually the easiest way would be to simply get rid of the entire collection. But since that would be boring, let's go with delete one to simply see how that works. Delete one takes a filter to find out which document to delete. And now you could filter for all kinds of things. A filter is defined as a document, so with curly braces, and then in its simplest form, you now simply define which key and which value you want to delete, or the document with that key and value you want to delete. So for example, here we could say departure airport, if that is equal to TXL, so to Berlin Tegel, then I want to delete that document. And what this would do is, it would go ahead, find the first document in our database where the departure airport is TXL and delete it. So if I hit enter here, you see this was accepted, it was successful, and we see it deleted one document. So if we now again use our flight data and find all documents and pretty print them, we only see 2 documents now, the one with our custom ID and the first document we ever entered. This means that this middle document was now deleted, because it was the first document with a departure airport of TXL which it found. Obviously, we don't have to use the departure airport. We could have looked for an ID too. So I could also use db flight data delete 1. And I could have also looked for underscore ID and then maybe my custom ID, this one here, TXL LHR 1. If I do this, it would delete this document. But let me also show you how to delete many documents. Now, the thing is, we got nothing in common. If I just execute delete many like this, it fails though, so I need to pass in a criteria. Now, we got nothing in common for our elements here. So let's first of all update them real quick to add a new field to both documents so that they have something in common, so that we can delete them in bulk, so that I can also show you this. So for this, let's go back to the collection and now use update 1. Update 1 updates, as the name suggests, one element. And for update 1, we first of all define a filter where we say which document should be updated. And now let's say we want to start with this first element here. So I want to update the document where, in my case here, maybe distance is 12,000. This should select this first document. The second argument then is how I want to change it. And now the question is, what do you pass there? Now let's say we want to add a new field, and therefore we pass in document here, marker, which holds some text, delete. By the way, as you see here, you can use single quotation marks for the value too, but you can also use double quotation marks. Now, this might add a new field, marker, with the value delete to that first element. But if I hit enter, I actually get an error. And the error is that the update operation document must contain an atomic operator or atomic operators. Now, this is a very weird error, and there's not really much you can do with it if you're just starting with MongoDB. The thing is, it simply is an incorrect type of data for updating. You don't pass in a document describing your change like this, because MongoDB doesn't know how to interpret this. Instead, what you do pass here is a document with curly braces with a special keyword, $set. And this is something you can remember. Whenever you see something with $, in MongoDB, it's a reserved operator or word. $set is simply identified by MongoDB when used in an update 1 operation to describe the changes you want to make. The value of $set then is a document with curly braces, and we need to close another pair of curly braces for our surrounding curly braces, now marked in purple. And now what this does is it tells MongoDB, hey, for this document you're finding, please set this value. And if this value did exist, it would change it to delete. And if it does not exist, as in our case, it will add it. So if I now hit enter, this succeeded. You see it found one document that matched our filter, and it modified one document then. And now if I again access my flight data, find it, and pretty print it like this, we see we now added the marker here. Now let's say I want to add that marker to all my documents. Now what you can do then is you can use update many. So on flight data, you can use update many. And now you need to pass something as a filter, but you can simply pass empty curly braces. And we could have done that on delete many too, by the way. This will select all documents. And now here, I again use set and then describe what to change. And now let's say I'll set the marker to delete here. So not delete, but to delete. If you hit enter, you see it matched 2 documents and it modified 2 documents. And now, if you again access your flight data, you find it and you pretty print it, you see that both now have the marker to delete. Please also note that for the first document, this was delete before and it was changed to delete. And now with that, we can use that marker to delete all. Now, as I mentioned, what we could do here is we could also use delete many and pass an empty pair of curly braces too. This should delete all elements. But of course, I also wanted to show you how to use update. So here, I will now use my new condition and check for all elements where the marker is to delete. And if we now hit enter, you see this was accepted and 2 elements were deleted. And now if I access flight data and I use find and pretty print this, well, we get back nothing because there's nothing in there anymore. So this is how we can insert elements, how we can delete and update them, and how we find them, but it's not all I wanted to show you. Let's continue in the next lecture. We saw how we can insert, update, and delete things in the last lecture, and therefore our flight data now is empty, as we can confirm if we run find. Nothing is returned. Now, time to add something again. And there was this file you found attached earlier. You can find it attached again to this lecture. It holds an array of JSON documents. And now I want to use the entire array. So make sure to copy the entire file content. And then back in the shell, let's again access our flight data and use insert many now. Insert many now allows you, well, as the name suggests, to insert many elements. And this is actually not done by adding many elements separated by commas, but instead by passing an array. So exactly the kind of data we got. Let's delete the closing parentheses and paste that in, and then add the closing parentheses after the closing square brackets. And with that, if you now hit enter, you see this was accepted and it inserted 2 IDs. And there you also see this order it automatically keeps, which I mentioned. It's almost the same ID, but the second ID has a C at the end, and therefore it will be ordered after the first element, which makes sense because it was the second element inserted, so MongoDB keeps the order here. And now if we again access our flight data and find it all and pretty print it, here is our flight data with the automatically added IDs. So this is now insert many, and now you saw both insert one and insert many. You also saw update one and update many, and delete one and delete many. There's another thing I want to show you though, and that is related to finding data. We got our flights in the database again, and now let me dive a bit deeper into how we can find data. Thus far, we always used this way of finding data. Find with no arguments. Now, just as you can filter for specific records or documents when deleting or updating, you can also do so when finding. So I can access my flight data here. Let me quickly clear this to make it a bit easier to read. And instead of passing nothing, you can pass a document to it, which will be interpreted as a filter for your collection. And you can filter for anything that makes sense. You could filter for a name equal to max, but of course this returns nothing because in our collection we got these 2 flights and there is no name field in there. But what we can do, of course, is we can use flight data and find all flights that are, let's say, intercontinental. So we use that key here. We do so by adding a document, then the name, and this can be wrapped by quotation marks, but it doesn't have to. And then let's say I want to find all flights where this is true. This would be a valid filter. If I now pretty print this, which always is optional, just to make it easier to read, if I hit enter, now I get one flight, and this is this one flight, which is an intercontinental flight. Of course, this is a very useful feature because in pretty much every application you're creating, you are not always interested in all your data, but in a subset of the data, which you need for that specific web page you're showing to the user or that specific part of your mobile app. You're also not limited to simple queries like this. We could also find all flights with a distance greater than 10,000 kilometers. And for this, we just need to modify the syntax a bit more. It's easy to look for equal values. Distance 12,000 like this, that would be simple, and it gives us back this one flight, here just not pretty printed. But if we want to have a greater than check, we can do that too. And there we just need to pass another document or object. I'll use these words interchangeably. We need to pass another object as a value for distance. And here we again use one of these special operators provided by MongoDB. $GT, which stands for greater than. And no worries, you don't need to learn them by heart right now. GT does exist, $GT, and that means greater than. And then you enter the value which you want to have as a greater than value. So here we could enter 10,000. And let's also pretty print this to make it a bit easier to read. And we get this one flight which has a distance greater than 10,000. The other flight had a distance of 950. And therefore, if I modify this to look for all flights with a distance greater than 900, we actually get back both flights. So this is of course another very useful feature. Now let me close this lecture or end this lecture by showing you find one with this example. So I'm looking for flights with a distance greater than 900 kilometers. If I switch it from find to find one, and I remove pretty here, because pretty is not supported on find one, I get back only one flight, the first flight that matched my criteria. And that makes sense because find one only gives me back one element. So if I want to find all, I should use find. If I'm only interested in the first matching element, find one is the solution. The important is it will still respect that filter, but then not look for all matching elements, but only the first matching element. Now with the basic CRUD operations covered, let's dive a bit deeper. And let's dive a bit deeper into update. First of all, let's have a quick look at all our data in the collection again. We got these two flights. And now let's say I want to change the first flight. I want to change it by adding an extra field, which simply holds the information whether the flight is delayed or not. Now we can do that by accessing flight data here, and then using update one. And I can filter by ID. We can copy that object ID, and it's important that you copy the whole object. We could filter for underscore ID with this object ID. Now this will select this first flight, and now you learned we can pass a document with $set where we can tell what to change. For example, can set delayed to true. If I now hit enter, this was accepted. And if I output all the flights again, we see delayed was added. So this is something we can do and something we already saw. Now there also is another command we could use. And that is not update one, but just update. So let me quickly remove the one here and now just use update. If I do that, you see it generally worked, but nothing was modified. And the reason for that simply is that we already had a value of true here. So if I change delay to false, you see it did modify one element. And if I now output all the data, we see delayed is false. Now update works a bit like update many. Update many was used to update all matching elements, and update would also update all matching elements. So what's the difference between update and update many then? The difference can be seen if I actually remove $set here. So if my second argument is now just delayed false in a document. Remember, with update one, this gave us an error. And the same, by the way, is true if you would use update many here. You also get an error here. Now with update, so just update without many or one, this actually works. You see it was accepted and one document is changed. Now how would you imagine that our flight looks like right now? Well, let's access the flight data and find it all and output it. And what we see is we got two documents, but the first one is very small because it now only has delayed false and the ID. The ID still is the old ID, by the way. This was not changed. It still is the ID. It did not change that, but it overrode all the other key value pairs. And that is the thing about update. Update does accept this syntax with just an object, and it will then take this object and basically replace the existing object with this new object, with this new document. It will only keep the ID. It will only patch the existing object instead of replace it, like update one and many do it, if you use the $set way. If you use it like this, you overwrite it. Maybe this is what you want, but it is something to be aware of. And in general, I recommend using update one and many to avoid this issue. If you want to replace something, you should use a different method. On flight data, you should then use replace one. And there you again place your filter. So looking for ID equal to our object ID. And then you add the element you want to replace it with as a second value. So here I'll take my flight data from the attached JSON document, which was attached to earlier lectures, copy that, delete the closing parentheses, add my document and now close it. And if I now hit enter, you see one element was modified. And if we now output all the elements again, you see the ID still is the same as before. It's the ID we looked for in the filter, but the rest was replaced. And this is simply a more explicit and therefore safer way of replacing the data if you really want to replace it. Otherwise, if you just want to change it, partially change it maybe, use update one or update many. Be aware of the behavior of update. We worked with our flight data quite a bit. Now let me add another kind of data. I'll clear the console with the CLS command for that. And now I'll add a passengers collection to my flights database. And I want to insert many passengers in there. Now you find a file attached to this video, the passengers JSON file, with an array of passenger data, just some dummy names and ages. Copy that and add it here, and add a closing parentheses at the end and hit enter. And this should insert many elements with the insert many command with all these automatically generated IDs. Now we can have a look at that data by accessing passengers, and you can always just type and then use tab autocompletion here, by the way. So simply hit tab in the shell and it should autocomplete. You can find them and pretty print the results. There are our passengers. Now on first sight this might look good, but actually if you have a look at the last entry, Albert 2 Stone, and then you have a look at the data you found attached, you will see that Albert is not the last entry. Gordon Black actually is. Now the order here is the same order as it was added to the database. So where is Gordon? Well, you also see the type IT for more. If we type IT, then we see Gordon Black. Now this IT command is a feature shown in the shell. I will show you another way of getting the data if you were using a MongoDB driver in an application in a second. But the fact that we had to use that is not shell specific. Instead, find, so passengers, find, or the find command in general, no matter on which collection you use it, gives you back a cursor and not all the data. Previously, it looked like it always gives us back all the data, but actually it gives us a so-called cursor object. Now what is that? Find does not give us an array of all the documents in a collection. And that makes a lot of sense because that collection could be very big. And if find would immediately send us back all documents, and you think about a collection with, let's say, 20 million documents, then this would take super long, but most importantly, it would send a lot of data over the wire. So instead of that, it gives us back a cursor object, which is an object with a lot of metadata behind it that allows us to cycle through the results. And that is what that IT command did. It basically used that cursor to fetch the next bunch of data. So find here really just gives us back that cursor. And we can actually see that by using some other methods here. For example, there is toArray. If you execute this, now you see Gordon Black as the last element, and now there is no type IT to see more, because toArray will actually go ahead and exhaust the cursor, so go through the entire list and fetch all the documents and not stop after the first 20, which by the way is simply a feature by the MongoDB shell. It gives you the first 20 documents automatically, but then stops. toArray simply gets them all and gives you an array. Now that might be fine here, but of course that is also not optimal if you got a lot of elements. In your application code, you would most likely use something like passengers, find, and then there is a for each method. And for each here simply allows you to write some code to do something on every element that is in your database, on every document you got in there. Now, the exact syntax you can use is something you can find in the driver docs for your driver. So if you're using PHP, check out the PHP MongoDB driver docs and you will see how to use that for each function. In JavaScript, and the shell is based on JavaScript, you could pass a JavaScript function to it using an arrow function here, where you will get an argument passed into the function automatically, and that will be your document. You can name this argument however you want. So in our case, it will be our passenger data. And then you can use it in here. And here in the shell, there's a print JSON command, which we can use to pass or to, pass our JSON data, which we want to output, like passenger data. And now we also get all the documents, because now what we're doing is on the cursor, which find does return, we execute the built-in for each method to execute this method here, this anonymous method, on every element. And the cursor will simply go through our entire collection, fetch all documents one at a time, execute that function on it, pass the document into the function, and then here we just happen to print it out like this. In your application, with your favorite language, you can of course do to the data whatever you want to do. Render it onto an HTML page, send it with an HTTP request, whatever you need to do. And that is just what I want you to take away from this lecture. Find does not by default give you all the documents, even though it looked like it did, because the shell actually gives you the first 20 documents by default. Instead, find gives you a cursor, and then it's up to you to use that cursor with toArray to force it to get all documents and put them into an array, or better, for large sets of documents, with for each. And there are more methods available, which you find in your driver docs. Technically, you need to know that with for each, it will really just fetch the next document for every loop cycle. So this is very efficient here because it does not fetch all the data in advance, load it into memory, and then force you to go through it with for each. Instead, it really just fetches the data on demand, therefore, of course, not overusing your bandwidth and not loading too much into memory. So this is the important thing to take away. Find gives you a cursor and not the element itself. This also is the reason why on find1 we could not use pretty. You remember, if I use passengers, find1, this works. Find1 pretty fails, because pretty is a method that simply exists on the cursor here. So this is why find1 does not support it, because find1 does not give us a cursor, because it only gives us one document anyways. Find gives us multiple documents, therefore we don't get the data immediately, we get the cursor instead. The shell happens to take that cursor and give us the first 20 documents by default, but we can also control that with for each or toArray, and here pretty exists because it is simply a method that exists on the cursor to pretty print the output. This is what you need to take away here. For the other methods like insert, update, and delete, cursors do not exist because these methods don't fetch data. They manipulate it instead. We already covered a lot about how to retrieve data, how to store data, update, and delete it. And we're nearing the end of this module. But before we conclude the module, there are two other important things you gotta know. And the first one is projection. Now, what is projection? Imagine you have this kind of data in your database. Some information about a person, in this case me, with name, age, job, and that ID. Now imagine in your application you don't need all that data. Maybe you just need the name and age for a given page on your website. Of course, you could fetch all the data and filter it in your application. In any programming language, you can of course manipulate the data you're getting back. But you would still transfer it over the wire. So you would kind of impact your bandwidth. You would fetch unnecessary data, and you want to prevent this. So it would be better to filter this out on the MongoDB server. And this is exactly what projection can help you with. Projection is super easy to use. Let me show it to you. We got our passengers, and on the passengers, let's do a quick find again. Here are our passengers. And now let's say I'm only interested in the names of the passengers. Now you can do projection by using find. Now you need to pass a first argument because I actually want to pass a second argument. And that first argument now is an empty document because I want to find all passengers and I don't want to pass a filter. And the second argument now allows us to project. And here, the projection is set up by passing another document, so another pair of curly braces. And here you simply specify which key value pairs you want to get. For that, you simply name the field you want to get. So let's say in our passengers, We have a name and we want to get that name. So we type name here, and then as a value, simply a 1. This means included in the data you're returning to me. If we now output that, we get all our fields with just the name and, well, still the ID. So the age is missing, and the age is of course not missing in the database, but only in the data we retrieved from it. So in the data we're showing here. So this is projection doing its job. But what about the ID? The ID is a special field in your data. By default, it's always included. So the default in general is everything is included. But even if you use projection, as we do it with the second argument, the ID is always included too. If you use projection like this, normally only what you add here, so name in this case, is included. But the ID is also always included. You have to explicitly exclude it if you don't want to add it. Now you exclude something by simply specifying its name and then using 0 instead of 1. We could do the same for age, but this is not required because the default for everything but the ID is that it's not included if you don't add it in your projection configuration. But for the ID, we have to be very clear about it. And now with that, if I hit enter, we get only the objects with the names. So this is projection doing its job. And the important thing to understand here is that this filtering or this data transformation is happening on the MongoDB server. So this happens before the data is shipped to you. And this is of course what you want, because then you don't get unnecessary data, you don't impact your bandwidth, and therefore you can only work with what you need in this case. We're almost done with this module. Now let me show you two other important pieces of data you can put into your documents. You can use embedded documents, and this is actually a core feature of MongoDB and a core feature I'll come back to in my data schema and relations module in this course. Let's imagine this box as one document. Embedded documents then simply means that you can have a field in your document, like name, but then this could be another document. So the value of the field could be another document. And you can have multiple such documents. And these documents can have other sub-documents, which can have other sub-documents. So you can nest your documents all in one overarching document in one collection. So here, we can have up to 100 levels of nesting in MongoDB. This is a hard limit, but you can have a lot of nesting. And to be honest, you rarely need more than 3 or 4 levels. And you also got another hard limit. The overall document size has to be below 16 megabytes. That might sound small, but since you only store text in there, you don't store files in MongoDB, for example, you would use your file storage for that. Since it's only text, 16 megabytes is actually quite a lot. Still, these are areas to keep in mind. So these are embedded documents. Another kind of data you can store are arrays. And this is not strictly linked to embedded documents, though it can also be documents. You can have arrays, in this case, of embedded documents, but arrays can hold any data. This simply means that you have lists of data in a document. Now, this is, of course, very theoretical here, so let me show you an example in the next lecture. Let's go back to our flight data. Let's quickly find all the flights here. This is our flight data. And now let's say we want to store the status for a flight. For this, I'll use my flight data and I'll update many elements. I'll pass an empty document as a filter to target them all. And then here we have $set and then how we want to change them. And now let's say we want to add a status field, but that status is not something like on time, which you could use. But let's say this is another document. So here another pair of curly braces. So this is now a value we set for status, which we add to our flight data. And now here you can enter anything which you can have in a document, multiple key value pairs, even other nested documents if you want. So here we could have a description field, which is on time, and maybe last updated, which is 1 hour ago. If we now hit enter here, it updated both documents because we had no filter. And if I now output my flight data in a pretty way, we see these nested documents here. And this is what's called embedded document. I use nested and embedded interchangeably here. So this is an embedded document. It's another JSON document within a wrapping JSON document. We got 2 documents in the collection, and each of these documents has a child document. And as I said, inside of the status, you could have another nested document. So if I would repeat my command here and add another value with maybe details, that could be another nested document, so another pair of curly braces. Maybe this has a responsible field, and there I put my name in there. If I now hit enter and I output all the flights again, now we see another nested document in there. So a nested document or an embedded document in an embedded document in a collection document. So these are embedded documents. And now we also can have arrays of data. Let's have a look at that in the next lecture. So we saw embedded documents. Let's now have a look at arrays of data. And for that, let's go back to our passengers. So remember, we got our passengers collection. If we find all entries there, this is how a passenger looks like. Now let's say we also record the hobbies of our passengers. For this, I'll edit Albert Twostone here with update 1. So by selecting the passenger with the name Albert Twostone, like this. And I'll update it by setting a new field there, hobbies, which is an array marked with squared brackets. So this is important. Now it's an array. And here we can have any kinds of data in there. We could have multiple documents in here. That would be fine. But we can also have multiple numbers or simply strings like sports and cooking. These are just strings, not documents. So any kind of data you can have in a document can also be in an array in a document. If I hit enter and I output my passengers, you see Albert now has hobbies. He's the only passenger with that because we filtered for him. And hobbies is now a list of data. It's not a nested or embedded document. It's a list of strings in this case. And as I said, this could be numbers. This could also be other documents. So you can also have documents in an array, and you can have arrays in documents. This is possible. You can even have arrays in nested documents. This is all possible. So in the last lectures, we learned about embedded or nested documents and arrays. And this gives you a lot of flexibility to structure your data in the way you need it to be structured. Also something I'll dive into deeper in my data schema and modeling and relations module in this course. One thing I want to do before I close or finish this module is I want to show you how you could access such structured data. And let's start with the hobbies here. You can, of course, output that by, let's say, finding Albert with find, and then I'll look for name Albert Twostone, like this. Now if I pretty print that, here's Albert. We can now access .hobbies here because find will give us that person and hobbies should give us access to the array here then. Though one important thing, we should use find1 here so that MongoDB knows we'll only have one element so that we can directly access the fields of that element after fetching it, so after the closing parentheses. With this, we indeed get the hobbies output here, sports and cooking. And we can even search for that. If we want to find all passengers with a hobby of sports, what we can do is we can access hobbies here, which is an array, and look for sports and output that in a pretty way. And here we find Albert too, the entire document, not just the sports entry, because we're looking for the entire passenger documents where hobbies is equal to sports, and MongoDB is clever enough to see that hobbies actually is an array, so it will simply look if that array has one element named sports, and then it gives us the entire document as a result. So this is how we can also query such arrays. Now, how can we query objects? Remember, we had nested objects, nested documents in our flight data. So here, if I find all, we had the status. Now, if we want to find all results with a status description of on time, we can use our flight data and find. And now in the filter, we want to look for the status, but the status, well, we're interested in one of the fields of that nested document. For this, we can use status dot and then the nested field. So you use dot notation to drill into your embedded document. So dot description. Important when using that. So when having a dot in here, when using such a path to a nested field, you need to wrap the entire term with double quotation marks though. Otherwise it will fail. And now we can check where is this equal to on time. If I now print this, I get both my flights because both have status description of on time. We get no error. Instead, this query works. So we can drill into embedded documents with that dot notation. And obviously we can go one level further as far as we need to. We can also drill into details. So if we're looking for our details here and we want to find all flights where details responsible is Max Schwarzmuller, we can do that too. Now I'm drilling into details responsible and I'm looking for Max Schwarzmuller here. And I again find both flights because both have Max Schwarzmuller as a responsible person. So this dot notation is also something you'll see a lot in this course, as this is an important syntax that allows you to look into embedded documents in your filters. And this is it for now. We'll dive much deeper into all of that and how to write efficient queries and how to access your data and work with it. We'll dive into all of that throughout the course. These are the core things you gotta know about how MongoDB works, how you can work with it, how you can store, update, delete, and read data, and how you can also structure your data. Now, as I mentioned, we'll have a whole module where I dive into how to optimally or cleverly structure your data and how to work with related data, but this is now a good start. Let's practice this before we learn about a different way of looking into your data.